Hello everyone, and thank you for joining us for another Maximum Code tutorial. This is a continuation tutorial for accessing SQL database using C#. We'll go over SqlCommand and SqlDataReader. So let's get started and kind of review what we did with the Docker image when we downloaded SQL Server. As you can see, our image is running, and this is the image we downloaded. It was the latest of the SQL Server in Docker, and it's in use. If you go back in the container apps, we can see that our Docker image is running, and we can see the same information we showed the last time. And if we go back and click the container image, and now we can see some logs. These are the logs SQL is outputting to the console. And if we inspect, these are the environment variables and the port that we told SQL to run under in the Docker. And we can actually look at statistics. You can see our CPU usage, memory, network, and this read-write, because there's nothing happening, so that's why it's 0. And as you can see, we have some commands up on the right-hand side. We have the CLI that we can use. We can stop our container, and then we can delete or we can restart it. So if we go back and take the command that we had by and running the container, this is what we used the last time. What was going to happen is, so if we go to command line and execute this, it's actually going to generate an error. And the reason for this is that we're trying to bind the port and the local host, and you can't do that. They're both, our other container is actually running. And so because it's localhost 1433, you can't bind this to the same port. So in order to get this going, you can actually stop this, and then you can run the other container. And as you can see, you have the name. This one is Vigilant Merzakani. And basically, if you don't specify a name, one will be created for you. So we're going to go ahead and delete ours. So that name, and because we ran the command and we didn't specify one, that was generated for us by Docker. And so if we go back to the CLI, if you look there in the header, we actually see the command that's being executed. This is the Docker executable -it, and then a hash, and then it is the bin sh. So basically here we're telling Docker to attach to our image. That way we can run bash commands through this console. And we can show this by taking this command that we have and basically run the SQL command in a CLI and see the results. So basically we're telling it to go ahead, run the SQL command, the localhost, which is our local address, IP address, our username and password. Because this is bash, we have to escape the $signs in our password. And now we're gonna we get this line 1, and if we put a command like select a version, we have to give it a terminate statement like go to actually execute the command for us. And if we do the same thing in SQL, you'll notice that we have the same exact result coming back from SQL Server. And as you can see, we also installed 2 more databases, Northwind and Pubs, and as you can see, we have additional tables, we have some views we can work with, we have some stored procedures. We'll use all of this inside our code. In the Pubs database, there's no functions here, so we may have to create one so you can see how we can execute functions. Should be the same as the stored procedure. So this is the Northwind sample that is then uploaded into the Microsoft sample, and also Pubs, which is a very old database about books that Microsoft had first created for SQL Server 6.5 or 6.0. As you can see, there's some authors, employees, and so forth, and there's also there's only one view and some very few stored procedures, and they're really more for reporting purposes. We'll probably be using the Northwind as well as our own samples. And if we go to the Microsoft website under SQL Server samples, as you can see, there is the 2 SQL commands that we used. We'll include this within our sample code so that you can actually don't have to go here, but if you wanted to stay up to date with the latest changes, you can just come here and take a look and see if there was any changes. There's also another URL. If you search Google through SQL Server container image with Docker, as you can see, you have multiple commands that you can use, from PowerShell to Bash to command line. And then you can actually, this is the command that we use to pull, and then we use the command to run the container. And notice that here we have a -- name SQL1, which means that it will name the container SQL1 rather than getting the its own internal if we don't pass one. And if we say docker ps -a, basically what that'll do is it will show us the images that are installed within our container within Docker, and we have only one. So as you can see, you can now, this is the docker exec -it, and that's the command that we used. We went through the UI and it did it for us. It uses the hash, but if you wanted to do this through the command line, you would actually do the same thing and just give it the container name and it would run. And in this command, basically they are updating the SA password to be a much more strong password. So we'll go ahead and let you play around with that. Let's go to our Visual Studio and actually see some of these SqlCommand and SqlDataReader in action. So let's go ahead and actually create a connection string builder and a SQL connection so that we can actually connect to our SQL before we run the SQL command and the data reader. This should be familiar with you. We did it before. We're going to use the object initialization So something we should go over, and you've seen us do this before using a using statement. And the reason is because if you look at the SQL connection, it is inheriting from DB connection, and DB connection is has an interface like disposable, which means that we should have a using statement so that when the scope, the SQL connection goes out of scope, .NET will automatically clean up the resources for us. So in this usage, we have the curly brackets open and close, but there is a shorter command that we can use by removing the brackets. So let's go ahead and now create a SQL command. There's a couple of ways to create a SQL command. We can just create a SQL command, as you can see now has some constructors, and we can pass it the string text, SQL connection, some transaction, and some other information. But by default, generally the way it's created is creating a new SQL command and then set the connection by passing the SQL connection as a property. So we should always remember to open the connection before using it. Otherwise, when you execute the command, it will generate an error. So we're going to use object initialization here as well. And if we look at the SQL command, which inherits from DB command, which is a base class, it also inherits from iDisposable, which means we have to also use a using statement so that when the SQL command goes out of scope, we also dispose it, and we should always clean up resources that we no longer need. So now that we've given the SQL connection object, we need to tell it what type of command we are running. You have the stars, and then you have some looks like duplicates. The stars are basically the IntelliCode. It's the AI that's suggesting those for us, but really you have three of them. You have direct, store procedure, and text, which is TSQL. So we're just going to use the table direct. This is actually going to generate an error for us, but we just want to show you to see what that's going to look like. This is actually implemented for the .NET framework, but not for .NET Core. So if you run this in the framework and you run this, you will actually give the text the table name, and it would actually get you all of the data for this. Once you execute it, you would get all of the data from the table. So now that we have the table name, we are going to execute the command that is going to return a SQL data reader back to us. So as you can see, while trying to do execute reader, we have quite a few other methods available for us. We have end execute reader and some other ones, but if we look, we also have some begin execute reader as well. and some other methods. And this is really the old way that you would do asynchronous programming. So it's there for backward compatibility. Generally, this is not used. If you did use this, you would call it, you would have an iasync result coming back. When you went to the end one, you would actually pass this back as a parameter to the method, and when the command was executed, you would get a result back. Since we're not going to do any asynchronous programming, there is also execute reader async as well, which is if you do asynchronous program, that's what you should use. Since in this example we just want to go straight synchronous just for examples, we'll just go ahead and use the execute reader. So we also have execute non-query. You're getting an int back. This is usually for SQL statements, and once it's executed, it'll return an int value of how many records were updated or deleted or inserted. And then you have the reader, which will pass you back a reader. You have the scalar, and you have the XML reader. So each one will return a different data type that we will see in action. So we'll go ahead and use the execute reader. And if you look at the execute reader method, there's some overrides in here that we can use. So the first one is if you execute it without anything, you get back a SQL data reader. If you choose the second option, you're basically getting back a DB data reader. And if we go to the third option, we're getting a command behavior. So what the command behavior is, we're basically telling it that when the reader goes out of, if the connection is closed, also go ahead and close the reader. This is a good technique to use if you don't close your reader, so that this way when the connection goes out of scope, it actually will clean up the SQL data for you. So now that we have a SQL reader, how do you read data from it? Well, you can, so here's the method for closing, but if you do that, then we can use the data reader, SQL data reader. So and also there's a dispose as well. So what we want to do is we want to read the data from the reader. So we'll also put a using statement here as well, because it does inherit from iDisposable. So the method, or excuse me, the property that has rows, basically will give us a Boolean value that there are records coming back, and the read method is the one that we want to use because it's a stream and it's a cursor forward only. When you say read, it will read to the first row and it will return true, and then you can actually use the reader. So here, because we use it in a loop, we read the first row, we can then access the that row within the reader. So now we're gonna pass the SQL reader, and then we're gonna say the current row, which is gonna be the row that you're on now, and then we're gonna ask for the column 0. You can pass either index value, or you can actually pass a string of the column name. So for this one, because we only have 2 columns coming back, as you can see, you have ID and test data. We'll just say 0 and 1. But you can pass the name, or you can actually pass a data column as well. So for this one, let's just name it ID, so that you can see how this actually works. That you can do it either with an index or with a string. So notice that we said that this is going to generate an error. Let's take a look at what that error is. So it's taking a little bit long time, which means that we have an issue connecting to our database. It's probably going to time out. Okay, so it's saying that cannot open database SQL example with the login information we passed it. That's because we did not spell the SQL example database correctly, so it really should be SQL examples with an S at the end. Let's go ahead and fix that really quickly. So now if we execute it, we should get the correct error. And we do. Now it says the command type enumeration value 512 is not supported by the .NET Framework SQL Client data provider. And if we go to this enum, you'll notice that it is the 512 integer value. So how do you get around this? Pretty easy. We'll just have to instead just use the text, the command type of text, and change the command text to select star from the table. So if you take this command and execute it within the SQL, we get the same result that we were expecting. So now if we execute it, you should see the rows and records coming back. And we have 2 rows and 2 columns that are coming back. So let's go ahead and actually take this TSQL and convert it to a store procedure, which is going to be a very simple store procedure that we're going to call, and it's going to have just select star from table. And if you use the SQL Manager by default, you get this template. You can go there and manually change the values, or you can actually, there's an icon for the parameters that are in the template. You'll get a dialog box, and that has all the information. You can go ahead and change all of the values, and it will actually, when you select OK, it will update the template for you with the values that you added in there. So let's go ahead and name our store procedure. We don't need any parameters. We can actually leave these out and delete them manually. We click OK. As you can see, all of the information is updated. Go ahead and delete the parameters. You can take out some of the other documentation. Take that out as well. Now we do have the select no count on. This is if you had multiple or extra results coming back. Maybe we don't want it to interfere with the select statement that we're going to get, so we'll keep that by default. We'll see how that actually works in a later example. The scenario here is to just use the store procedure. If we now right click for it and say execute in SQL Manager, you'll see that it generates the code for us. And we get the results that we were using as before, using just the TSQL. You also have options to return not only the data from the select, but also an optional return value to let the command know if it was successful or -1, maybe it's not, or you can give it some other commands as well. If you are going to update a store procedure, you should use a alter command or create. Create is for new store procedures. Once the store procedure is created and you want to update it, you can use the alter command, or you can just right click on the store procedure, and if you click modify, it'll have the alter statement for you. And if we execute it successfully, but notice that we have this red squiggly line. That's because our cache is not updated. So if we go to IntelliSense and say refresh local cache, it should take a few seconds, and then it is updated, and now it actually recognizes that the store procedure actually do exist in our database. So let's go to our code, and the only thing we have to do is change this from the command to a store procedure, and then provide the name of the store procedure. And then if we execute this, it should be the same as before. We will get 2 columns and 2 rows. So now let's go to one of our other databases and try to execute a store procedure that requires a parameter. So in this example, we'll see how we can actually execute a store procedure that expects one or additional parameters be passed to it. So we have our customer store procedure, which is cust order history. As you can see, the parameters that we have is there are 2 parameters. There's one, a customer ID, and then there's a return integer value. So if you do the same thing this time to execute the store procedure, because SQL knows that it has a parameter, we need to pass it a value. And if we just enter 1, nothing happens because the customer ID is used in the where clause and that value doesn't exist. And if we actually go to the store procedure, we'll notice that the select has multiple tables joined. And one of them is the customer table, and then that customer table is where the where clause happens. So if we go into that table and view all the records, we can pick just one of them. We'll check the first one and we'll copy that. And if you go back to our store procedure, and instead of passing a 1 and we pass our value, we should now see a lot more results. So now let's execute this in code and see this in action. So the way to pass a parameter, we still use our SQL command. There's a parameter collection. Then we can say add, and then inside of the add, you can pass some values to it, like for example the parameter name and type, and maybe size of the type that we are passing. So ours is going to be not in varchar, it's going to be an inchar, but let's just put some defaults and now go back to SQL and see what that value looks like. So if we go back to our store procedure, notice that it is a inchar and the size of it is 5. Let's go ahead and change that. And then if we go back to see what the name of the parameter is, and let's go ahead and put that. It's important to make sure that the parameter name matches to the store procedure. And then, so if you look at the value coming back, it's a SQL parameter object. And we'll go ahead and use that to set the value. So now there are a couple of options. So parameters can go multiple ways. There are parameters that go in, and there are parameters that come out, and there are return parameters. So what are the parameters that we just used was a parameter that we passed in so that the store procedure could use it and act on it. And the out parameters are values that could come out of the store procedure. These are not the values we pass it. These are the store procedure. These are values that the store procedure will pass back to us. But store procedures can also return values, as you saw. So there are 3 different types of parameters that we can use: in, input, output, and return value. Let's take a look at those in action. So in this store procedure, we have ID, which is an in parameter, and at count, which is an output parameter. And we just create a SQL statement where we take the count from the query and add it into our output parameter. So if we execute this, the store procedure executes successfully. Now let's execute the store procedure, passing a value of 1 for the ID, and let's see the input and output parameters. And see how that would work with TSQL. So now that we have executed this, as you can see, now we have a add count and we have a return value. And if we go to our table, we added some rows in here so that you could see more than one data row is coming back. And so we have in this store procedure where we're executing it, we're creating 2 parameters, creating a return value of int and a count int. And we execute our store procedure, we take the return value of the store procedure and put it into the return value. And then we take the add count for an output, and then we do 2 selects to return those values back. So now if we go to the code and change this back to our example database. And let's change the store procedure name. And let's go ahead now figure out how to set the input parameters, which is going to be pretty normal. If we just don't specify it by default, it will be an input. So the ID is going to be an int. We don't have to specify the length of the int. And the value we're going to pass it is 1. And we'll rename this to ID param. And associate that to the command. So next what we're going to do is create our output parameter and return parameter. But I'm going to also show you how to put a direction to the parameter. Again, if you don't specify, by default it will be an input. So let's copy this and create our output parameter. So this is going to be our count. We don't have to specify a value because we expect that to be populated by the command object. Let's just copy this once more, and so we can have for our return. So now let's take the count parameter and associate that to command, and copy this once more for our return parameter. The return doesn't have to have a name. You can name it whatever you want, but the direction has to be return, and when we are reading it, it has to be the same name that you specified when you created the parameter. So we're going to call ours as return value. Change the direction to be return value. And associate it to the command. So everything else should be the same. Let's execute this to make sure everything is working. And we do see our data coming back. So now let's figure out how to output these values. So the way to get the information back is we take the parameter and we just call its value, and that should give us the value we're looking for. So let's do one more for our output parameter. And let's actually swap our values because we call this return, but we're having an output. Okay, so now let's execute this and see if it's going to show any information for us. So as you can see, there is no data being displayed for us. There's a reason. When you're executing a reader, you have to actually read the data and close the reader before you can read any of the parameters. So let's actually put it after a reader, but notice we haven't closed it. So let's run this. It should be the same as before. And we have no data. Now if we go back and close the reader, we should see our information. This is happening because the reader is a stream, and the stream has to be finished before we can pull the information back for the parameters. So as you can see, now we have a return 1 and output which is 3. So let's go back to our store procedure and take a look at something. go ahead and execute this so we can show you what it's going to look like if we take out the no count and what effect that has on SQL as well as when we're calling it. So if we go to the messages section, you see that we have one row affected twice, and that's because our select statements are being counted. So if we actually comment those out and execute again, notice that we have nothing in there. So let's uncomment those so we can see the values. So if we execute it again, it's just normal. So now let's go to our store procedure and remove the set no count. If we run it now, we have additional information that says 3 rows affected. Now this is happening because we first removed the no count, and it is actually getting the result of the count from our select statement. So now if we go to our code, we can read this to output this information by hooking to an event in the SQL command. So statement completed is the event we want to associate with. And let's go ahead and just output the event argument. And get the record count. And now if we execute this, we will see a value coming back. And that's because we commented that set no count. So if we update this again and run it, we should not see the value and the event that this does not fire. So now let's look at another command that we can use. If we go into our store procedure you'll notice that when we execute this, we get a dialog that shows us the parameter and the name, if it's an input output, and the data type. So how would you get this from the code, and can you do it? You can, because there are times where you'd want to get this information dynamically. So let's go ahead and copy our SQL Builder command and connection and bring it to our main method. So we have everything available for us, and now what we need to do is open the connection. Let's actually put this after the command. And now if you go to the SQL command, you'll see that you have plenty of methods in here, but unfortunately none of these have any kind of information as far as getting us the parameters that we're looking for, although there is a parameter method in here, or excuse me, a property. And but if you were to iterate through that, you wouldn't get the information that you're looking for. So what we need to do is populate that information. To do this, we'll have to use another object. So this object is going to be the SQL Command Builder. Now, if you new this object, you can see that it has some information you can pass into it, and it has additional properties in here. But it doesn't really give us anything additional, and the way you get the actual properties is that it is a static method called drive parameters, and then we pass our SQL command to it, and then it's going to populate the parameters. So what's going to happen here is that we're making a call to SQL, get the list of information we're looking for, and then populate the proper parameters object. So now if we iterate through the parameters collection, we should get our information back. There's one thing, whenever you're doing a for each and using a var, by default the parameter is going to be an object. So therefore, if you just do parameters dot, you can just get the basic object information, but you're not really getting the parameter object type that we're looking for. So let's go ahead and cast that to a parameter. Okay, so there's our SQL parameter object. And now if we go to the SQL parameter and do a dotted notation, you'll notice we get a lot more information back that is very specific to the SQL parameter. So we can get the SQL data type, and let's also get the type name. Now there is a SQL type name, but this is not the property that we're looking for, but let's actually use that for now to see what kind of information we get back. And let's also get the input or output direction. So this should be under direction. So let's go ahead and execute this. And if we look at the debug information, you see the input there is no type name. And if we go look at our direction, it is a return value. So let's go to the next parameter, and it's also a type, and the type name is also blank. And if you look at direction, it is an input. So let's go look at the parameter object and see which property we could be using, and it is the parameter name. So let's go ahead and put that parameter name and re-execute our code. And let's just continue for all three parameters and look at the output. And if you look, you'll notice that we have our int, our type name, and our direction. So now you could use the information to dynamically wire up your store procedure and the values and get the output information that you were looking for. So now let's take a look at how we can do the same thing, passing parameters to TSQL. So let's change our command type, and what we're going to do is grab our query, our store procedure with the parameter, and paste that in our command text. And now all we have to do is pass exactly the same parameter, name it @ID, and then add a value. And then let's just go and copy the reader part and output the results. And let's execute this. We should see the same output with the 2 columns and 3 rows. So we got an exception with a variable @ID. Okay, so we didn't associate the parameter to the command. So let's go ahead and quickly do that. And now our code should execute. And we see the same result. Now, some folks will not pass a parameter, and they will actually append a value to the string. And this is a scenario where you should never do. This opens you up to TSQL injection, and it's very dangerous. So we're showing you an example of what not to do. Although this will work, but it is not a proper way of setting up your TSQL. So now let's take a look at the SQL Reader and how we can work with that. We're going to just basically work with the current code. It could be TSQL or it could be a store procedure. It doesn't matter. And what we're going to do is basically pass our parameters and execute the reader. And then afterwards, we're going to get the schema, which is a data table. And then we'll watch this in the debugger and see what type of information. And a get schema table is basically returning us all the column values, like the ID and the data and the type of data type it is, if it accepts nullable or not. So let's actually take a look at this. So now if we go to the visualizer, we can see the column name is ID and the other one is test data. The ordinal column value is 0 and 1. and then you have some column sizes and some other information. The data type is the int and string that we're working with, and there's a bunch of other information here that you can take a look at. And you can also, if you're updating, for example, a table, you could actually read this and find some information, like maybe the column allows nulls or not, and you can decide what to do based on this. So it has a lot of useful information that you can pass back and use. So other things you could do is, once we are reading the reader, and inside of that we just basically output information like we did normally. But if you look at the array value that we are using on the reader is returning back an object. So we will have to convert this to an int or to a string, and this might cause boxing. If you have seen our other video tutorials, we do mention that. So if you look at the columns, the ID is int and the test data is a string. So what we can do is actually, in the reader, there's a method getInt32, and passing the ordinal value or the actual string representation of the column, and then it returns back a integer value for us. Same thing with getString. And if we do a dot notation there, you can see that there's many other types: get date time, decimal, double, boolean. So there's a lot of other types that we can convert if we know what type of values we're working with. So if we execute this, you'll notice that our SQL reader, if we iterate one more and look at the values, we have 1 and something, and we have converted that to the integer value of 1, and then the string that we are getting is also something. And you can also get the ordinal value of a column if you know the string representation of the column. In this case, we got the ID should be 0, and it is. So if we continue, we're going to now go talk about something else. This piece of code where we're actually working with the reader as an array of objects, we're going to show you something. What most people do is they take a method that goes to the database and they return a SQL data reader. So let's go ahead and comment these guys out. So then the code would go to the database, get the data reader, and then return that reader back to the caller. And this is one of the examples that we showed, that you should always use the close connection, because you don't know if the client that's calling this code may or may not call or close it. So this is important to have in there, so that when the connection is closed, the reader is also closed, so you're not leaking any objects. And you should ideally do this and try catch finally, and have your close in the finally. So what this happens when you pass the SQL data reader, you're creating a dependency on the data client. And what we want to do is show you a way not to have the dependency. And you can do this by creating a object array. So you read the reader same way as you did before. And then inside the reader, we create a object array with the field count of the reader. So there is a method, and then we pass the value, which is the arrays, into this method getValues, which returns back, which actually populates the values for us. So let's take a look at this in action. And then of course we put the data into a list of arrays. So if we execute the code now, we are inside the reader, so we're actually creating an object array of the field count. There's only 2 columns, So it's going to should create us two objects, and both of them should be null, and they are. And now we're going to pass this array to get values, and it'll get populated. It will also return back the fields as well, but we don't need that. As you can see, it got populated between 1 and 2. And then the next thing we do is we take our list of array objects and add it into it. So now if we finish the execution, and if we go back to our list of arrays, you'll see that we have 3 rows, and there's our data inside the array. And we can now pass this back to the client, and they can do some mapping on it as well. Now there is an issue here because the reader has a lot of more information, and what we are passing back does not have any of that additional data. But you could pass back the data table as well. So this concludes this part of the tutorial. The next part, we will look into dataset, data table, and data adapters. We'll see you next time. Thank you.